Okay, what we're going to start up today in our actual Unit 1 is we're going to start with lines. Lots of stuff we can do with lines. Lots of forms lines can take. So we're going to camp here for several days on graphing the forms they take, how to get the info out that we need, and then messing with those a bit. So this is going to be kind of a slow trek that we're going to be on here. So first things first, everything we are going to chat about here, I believe it's for the next 3 days, is going to be what's called linear relations. Otherwise, it makes a line, okay? So whenever something is linear, it's going to have AY and NX. There's not going to be any X squareds or anything fancy like that. We're just going to be getting these lines set up. Now, the first form we are going to look at is what's called standard form. Now, a couple things to know about standard form besides the fact that there's going to be a whole lot of variables here. So we got to explain what all the variables are. So, when we're doing standard form, A and B are not going to be fractions. If they are, we're going to fix it, because that's part of standard form, which is going to make a couple of the things that we do a little later in the week easier. C is just going to be a number. C can be anything. It can be positive, it can be negative, it can kind of work its way out. But A and B we got to be careful of. Also notice that the two variables, x and y, are on the same side together. That also needs to be true, because otherwise that can cause another issue. And one more thing, A must be positive. If it's not, we're going to have ways of fixing that too. So A and B, no fractions. A's got to be positive. They got to stay on the same side. This is why the notes can be so important as you're going, because that's a lot of information in like the first couple minutes here. So when this says write the equation in standard form, I've got to make sure it checks all the boxes. So I look at the first one. I'm like, okay, x and y are together. That's good. Step one, we're good. A and B aren't fractions. They're not. That's good. A must be positive. Uh-oh. All we got to do to fix that is divide by -1, because negative divided by negative is positive. But reminder, whatever you do to one piece, you must do to all. So all of them are going to be divided by -1. Then we check all three boxes. A and B on one side, A and B not fractions, A is positive. Once that's good, we're good. So, and actually, let's do this. Why am I calling it A and B? Why did I do that? You're like, I don't know, Hardy, why? Okay. Because this way we can put numbers on these. So it's got to be the three things. X and Y together, A and B not fractions. A has to be positive. So if I go through that checklist every time, I'm like, okay. I look at this next one. Hey, it's in slope-intercept form. Wait a minute. X and Y aren't on the same side together. That's a problem. We need to fix that. But they're on opposite sides of the equals. So how am I going to move the 2x over to the y side? How do I get this over here? Subtract. Now that's going to cause us a little different issue, but that's okay. Here's where I have to be cautious too, because I'm thinking like some of you are when we're doing these quizzes and stuff. This is not 2xy, okay? I minused that over. It's -2x and that positive or plus y. over here. We don't want the pluses and minuses to disappear. Okay, x and y are together. Great. A and b are not fractions. They're not. Great. A must be positive. Okay, we know this trick already. We saw it over here. So we just divide through by that negative. And you're like, okay, why exactly do we need to do this again? When you're graphing, there's going to be two main ways we do it. We're going to do it in slope-intercept form. Plot your 2 points and go. We're also going to do something tomorrow called x and y intercepts, which are very easy to do when you're in this form. So there's a method to the madness. It is not just Hardy trying to drive you insane. Okay? Okay, let's play with another one here. Let's play with one that's going to be a little easier. X and y together. Yep. They're not fractions. Yep. A must be positive. Yep. You're like, so we're done. Wait a minute. C's got to be on the other side. So these two need to be together. That's a good thing. But that has to go bye-bye. Because x and y are like, yeah, we don't want plain old numbers hanging out with us. We want to hang out. You don't have a variable. You're nothing. We don't need you here. So I can work that out. And so really the only thing that we haven't seen at this point, oh boy, our all-time favorites, the fractions. So let's see, can we remember back to unit 0? When we have fractions and we want to get rid of them, we want to multiply, but what am I going to multiply by? 12. We're going to multiply the denominators together. 4 times 3 is 12. And we're going to distribute that through, even to things that aren't fractions. Now, a couple of ways you can tackle this. As long as you put it in parentheses, you can just do it like this. 12 times 3/4, put it in parentheses. 12, oops, hang on a minute there. There we go. Times negative 1/3. Make sure you take the sign with you if it's negative. Minus 4y. And 12 times 1 is 12. Ooh, wait a minute. X and y are together. Check. Not fractions anymore. Check. A is positive. The number in front of x. Check. Sweet. One step, I'm done. I like that. That was good. Now, will I get that lucky every time with fractions? No. Sometimes I'm going to look and I'm like, oh, x and y together. Not yet. Positive y. We're going to subtract y from each side. And similar to what we saw up in number 2, don't smash these together. So 1/6 x minus y equals negative 2. Okay, x and y are together. Good. We only have one fraction this time, so how are we going to get rid of it? It's just the 6, so the 6 is going to distribute through this time. All the way through. Again, even if stuff isn't a fraction, we're going to take care of it. So we got x, or 1x is fine. It doesn't hurt. 6 times negative y is negative 6y. Because it's just like doing 6 times negative 1. And 6 times negative 2 is negative 12. X and y are together. Check. No more fractions. Check. Number in front of x, my a value is positive. Check. That's how we get to standard form. That will be a huge help to you tomorrow when we're doing X and Y intercepts. Okay? But it is a way that we can graph lines as well, which we'll chat about. The main character in graphing lines, though, you've probably been seeing this since pre-algebra, is slope-intercept form. Good old y equals mx plus b. Occasionally, and the only reason I'm writing this, it may be for now, it may be for future reference, sometimes y will get replaced by this thing, f of x. This is what you will see most of the time, though, okay, is y equals. And this is called slope-intercept form because the number in front of x is the slope, and the number on the end, this b, is the y-intercept. So pretty proper name here for what we're trying to do. And so the slope piece is what's called the rate of change between points. Okay, rise over run. We're going to put one other little note over here. The top of your slope fraction will tell you if you're going up or down. And the bottom of your slope fraction will tell you if you are going right or left. We've got to keep those straight. Those are not interchangeable. If we flip and do run over rise, oh dear, we're going to have all kinds of problems here. So, when we do slope, oh boy, there's 4 types. You may not have thought of that before. You're like, Hardy, there's positive and negative. What are we talking about here? So we're going to draw some pictures. We'll put some words in with it too. So let me make some little X and Y axes here. So we'll start with the normal ones. If you have a line that goes up to the right, bless you, that's a positive slope. If you have a line that goes down to the right, it's catching, bless you, we have a negative slope. We're always talking about left to right with these. But then the 2 oddballs that we don't think about sometimes. Well, what if it just goes sideways? What if it's horizontal? That's going to be 0 slope, which is different than our last one, when we have a vertical line going up and down. Which is called undefined. Now, let me kind of make one more little note here on this, because I think it'll help. When you're trying to tell the difference between 0 and undefined, when you're not looking at a picture, here's the thing. 0 will always be 0 over some number. 0 over 4, 0 over -2, whatever it happens to be. If it's undefined, it's going to be the other way around, and it's going to be some number divided by 0. But if I try to do that in my calculator, I'm going to get an error message. Hence, it's undefined. So we're just trying to kind of play with all this vocabulary stuff when we're doing this, because you're like, man, we haven't graphed any lines yet. This is supposed to be graphing lines. What's the deal? Oh, the lines are coming. They're about to come right now, so here we go. And then I think I'm going to start mixing. Yeah, I'm going to do that. We're going to change this up a little bit. I'm keeping this under 20 one way or another. Okay. Write the equation in slope-intercept form. If it's not already, then graph the line. Okay. Y equals 2/5 x plus 7. Hey, y is by itself. Mx plus b. Okay. So here, when I do these, the first thing I always want to do is label my y-intercept. When we do it this first time, I'm even going to put words with it here. And then second is when we're going to want to look at our slope and figure out what directions we're going to be going. So, job 1. Find my y, not x, intercept. So, let's see here. 1, 2, 3, 4, 5, 6, 7. Okay, there's my first dot. We like to have 3 dots with these. If we get stuck with 2, whatever. So positive 2 over positive 5. Positive on top is up. Positive on the bottom is right. Now you're like, Hardy, way to go, dude. Like, we're going to guesstimate on this first one. So I'm going to go a little above the graph here, because that's my up 2. 1, 2. You're like, but I can't do that again. So what the heck? If you run out of room with this, you have an option. You have an option of saying, hey, I can do the opposite of both of these, and it'll be on the same line. Now watch this. So I'm changing the sign on both. So if I do, that means I would go 2 down and 5 left. So if I start back here and I go down 2 and 5 left, they all end up on the same line. And I'm set. So when you're doing these, again, f of x and y are the same thing. Label your stuff. What number is there if I don't see a number in front of a variable? Okay, in this case, that'd be -1. Now, it doesn't mean it's -1 over -1. That'd be +1. So it's just -1 over +1. We always want slope to be a fraction, even if it's not originally. So I plot my y-intercept first, my b. Do you have to write down every single time what direction it is? If you're feeling good, no. But if graphing's never been a strength, I would. 1 down, 1 right. 1 down, 1 right. Make a few dots. Connect the dots. Negative slope going down to the right. Number 1, positive slope going up to the right. So there's lots of little check marks in here to make sure we're going good. All right, let me get these last 2, and then I'm going to kind of remind myself of cutting myself off here. Now, if it's not in slope-intercept, because we haven't learned the x and y-intercept stuff yet, we're going to go ahead and we're going to get y by itself, because that's what slope-intercept form is. So that's positive 1x. We're going to take 1 from each side. Now, here's a place that people tell me I'm picky. I don't think I am. Notice when you look at your form, the x part is first, the number part is second. We've seen that on the first 2. We're going to keep that going here. The x part is first, the plain number part is second. That's going to save you problems when you're graphing. So are we ready to graph? Almost. What's my last step to get y alone? Divide by 3. So what? Uh-oh. Hardy, I got a fraction. That's okay. Fractions aren't a bad thing. But I think negative 15 divided by 3 is negative 5. Okay. When you have a negative slope, the negative only goes on one number. So here, there's my b, there's my first point, negative 5 on the y-axis. But when we do the slope, that 3 is positive. So I'm going to go 1 down, and I'm going to go 3 right. And I'm going to go 1 down, I'm going to go 3 right. And as long as the 3 points you plot all look like they make a line, there's no oddball, go for it. You don't have to go both ways every time. So keep reminding yourself of these when we're graphing. The goal is to get the y by itself, by whatever means necessary. Could you do both of these at once? Maybe, but I'm not going to do it. So I got the minus 1 out of there because y needs to be alone. I'm going to get the 4x out of there with an opposite because y needs to be alone. And again, like we saw in the last one, make sure your x term is first. And then if that's a positive 1, we'll just put the plus in there. Hey, didn't have to divide or nothing this time. That's by itself. I am going to make it a fraction, though. Every time. There's my b. We always do that first. Always on the y-axis. Now, with my slope, I'm going to go down 4. And I'm going to go right 1. Can I do it again? Yep, I still got room. Looks like they make a line to me. And we're ready to rock and roll. So, I'm going to have to adjust the practice a little here because I didn't quite get where I thought I was going to, but that's okay. So here's what we're going to do on the practice. So we made it to there. Okay, let's check this out. Oh, dear. Dang, that's easy peasy lemon squeezy. All right. Page 1. Okay, just page 1. Because I didn't get to some of the other stuff yet. We'll do that tomorrow. So page 1 only today, and we'll tackle vertical and horizontal and parallel and perpendicular and all that other stuff tomorrow.